Hello everyone, welcome to Unit 4, which is all about matrices. We're in Unit 4 of our Algebra 2 course. This first lesson will be an introduction to matrices, and we'll look at some basic operations with them. So, I bet you can imagine what goes in this blank right here. A matrix is a rectangular arrangement of numbers. A matrix can be used to solve many different types of information, to store, many types of information. Some examples might include the prices of different items, the number of purchases made from those different items. Common use of matrices is for representing images. The red, green, and blue values of pixels on a screen or in a digital image is stored in a matrix. Also very common use in geometry. The rotational matrix and other kind of transformations are often done with matrices. And finally, we'll look at using matrices as a coefficients and constants in a system of equations. So we'll be using them to do Moore's techniques like what we did in Unit 3. All right, so let's get right to it. This is in a matrix right here. We have matrix A. It's got a name, right? We've named it matrix A, so we can say that. Matrix A has 1, 2 rows and 1, 2, 3 columns, and therefore we call it a 2 by 3 matrix. So you oftentimes hear we say, oh, we have a 2 by 3 matrix, a 4 by 4 matrix. It's telling you the number of rows, x number of columns. We can also describe specific elements in the matrix. For example, the element in row 1, column 2, is noted A1, comma 2, and that is A2. Note that the first row is row 1 and the first column is column 1. A2, 3, so that would be row 2, column 3 is a negative 2. All right, so why don't you take a second, just practice with that general vocabulary. Pause the video and fill in these different blanks best you can. Okay, matrix B has 3 rows and 3 columns, so it's a 3 by 3 matrix. Because the number of rows equals the number of columns, what do you think we call this? Matrix B is it's a square. It's not a rectangular array, it's a square array. Well, it is a rectangular array, but more specifically, it's a square array. All right, B1, 1. So row 1, column 1 is a 0. All right, row 1, column 1. Sometimes this is difficult for me to do because we also use matrices in computer science, but we usually start counting the rows and columns at 0. But we don't do that in algebra class, so be careful with that. So row 1, column 3 is a 2. The number 4 is in row 2 and column 3, so it would be B2, comma 3. The addition and subtraction of two matrices A and B is defined only if the size of matrix A and B are the same. Or in other words, we could use a different word than size. Let's say dimensions. That would be more specific, right? The dimensions have to be the same. So 2 by 3s can add with 2 by 3s, 3 by 3s with 3 by 3s, but they don't play well with others. In other words, the number of rows in matrix A must equal the number of rows in matrix B. And the number of columns in matrix A must equal the number of columns in matrix B. If defined, to add or subtract matrices together, we simply add or subtract the corresponding elements. So let's try that. We're going to add these two matrices together. And I'll just go ahead and form my answer matrix. So I add 3 plus 4 is 7. 10 plus 5 is 15. 1 plus 8 is 9. And negative 2 plus 2 is 0. All right, I can also define the two matrices and just say A minus B. So that's just another way of doing that. So let's write that out. 1, 3, 2, negative 5, 0, 11. Minus 3, 2, 0, 1, 2, 1. It is defined as a 3 by 3, right? 2 by 3 minus a 2 by 3. So 1 minus 3 is negative 2. 3 minus 2 is 1. 2 minus 0 is 2. Negative 5 minus 1 is negative 6. 0 minus 2 is negative 2. And 11 minus 1 is 10. Okay, on the next one, this is a 2 by 3. And this is a 3 by 2. It's not defined. The addition of these two matrices is not defined. Okay, I'd like you to pause the video, please, and work these practice problems. 2 minus 1 is 1. 3 minus a negative 5 is 3 plus 5 is 8. 4 minus 6 is a negative 2. And a negative 12 minus a negative 2 is a negative 10. This kind of shows just how difficult subtracting can be. So one of the things that you'll see me do a lot, and I kind of recommend it, especially when you've got subtracting and negative numbers, is to change it to plus and go ahead and distribute the negative. Because it's really easy to mix up your signs when you do that. So I think it's better to do that, actually. So let me make sure I did that right. 2, and then I can just see it's 2 minus 1 is 1. 3 plus 5 is 8. 4 minus 6 is negative 2. Negative 12 plus 2 is negative 10. Makes it a lot easier, I think. So then you just look at the sign. If it's a negative, subtract. If it's a positive, add it. All right, we're going to add m and n. Oh, wait a minute, though. This is a 2 by 2, and this is a 2 by 3. I almost didn't notice that third column. That's not defined, y'all. Did you catch that? I hope so. All right, if you haven't already, there is, I think, a couple more. Well, there's one more practice problem, so give this one a try if you haven't already. Okay, 4 plus 3 is 7. 0 plus a negative 1 is a negative 1. And 1 plus 2 is 3. So these are kind of unusual matrices. They're oftentimes called a vector because they're just one row of a matrix. All right, a quantity is defined as a single number is called a scalar. So called because they scale the matrix. Scalar multiplication of a matrix requires multiplying each element in the matrix by the scalar. So let's go ahead and multiply by a scalar here. We have 3 times 1 is 3, and 3 times 10 is 30. 3 times a negative 2 is a negative 6, and 3 times 4 is 12. So scalar multiplication is always defined. You just simply multiply it because it's one number. You just multiply it to each and every one, and it just kind of scales up all these values. All right, practice 1.3. I'd like you to work these problems here. Pause the video and do it. Okay, so hopefully you multiplied each one of these numbers by negative a half, so that becomes a negative 2, a positive 3, a negative 1, and a negative 5 over 2. On the next one, you should multiply by the scalar first. And the scalar is only multiplied to that first matrix. All right, then we'll add them together, and I get 4, 8, 11, negative 7, 3, 4. Okie dokie. All right, I got another kind of problem for us to work. We can also have some unknown quantities here in what's called a matrix equation. So I see that this left-hand side of this matrix equation must equal another, so we can do some basic algebra with matrices. First, let's perform the scalar multiplication. So I've got 4 minus 2, 2, and 2x. And we're going to be adding that to 3y, 0, 3, and 6. And the result is 10, negative 2, 5, and 8. So what does that tell me? Well, that tells me that 4 plus 3y must equal 10. So y is equal to, so 3y is equal to 6, so y is 2. And it also tells me that 2x plus 6 is equal to 8. So 2x is equal to 2, so x is equal to 1. And that's how that works. All right, you try the practice problem, please. Okay, hopefully you had some success with that. We're going to apply this scalar of negative 1 first. All right, well, what does that tell me? Well, that tells me that negative y plus 2x must equal 4. Ooh, I can't solve that, though. It's two unknowns. But using the second statement, I can see that negative x plus 2y is equal to 1. Now I've got two variables, two equations, so I can solve this. I'm going to do just a little bit of rearranging. I'm going to rewrite this top equation as 2x minus y equals 4. And the bottom equation I'm going to multiply by 2, making it negative 2x plus 4y is equal to 2. I'll add these two equations together. I get 3y equals 6, so y equals 2. Now that I know that, I can say negative 2 plus 2x equals 4. So 2y is equal to 6. So y, oop, wait a minute, that's not a y. It was a negative y, so negative 2 plus 2x. Let's say I've already found y. So 2x is equal to 6, so x is equal to 3. So we found their x and y values for that one as well. All right, well, that is the end of this lesson. So I want you to practice this now with your assignments, and then I will see you in the next video.